Welcome to a new Voltlog. In this video we are taking a look at the Owon HDS242S, which is a dual channel 40 MHz portable oscilloscope coupled with a 20,000 count true RMS digital multimeter and an arbitrary waveform generator capable of 25 MHz sine wave and 5 MHz square wave. And you get all of these features in a portable format with a 3.5-inch color TFT display. As part of their lineup, you can also get the HDS242S, which bumps the oscilloscope up to 70 MHz, and you can also get these without the function generator option, and those will not have the ending S in their model number. I received this instrument from banggood.com for the purpose of this review, and there will be a link in the description below, so if you're looking to get one, please check out that referral link. They have this on special right now, and it's usually available in their EU warehouse. For example, I got mine delivered in less than a week via courier with no additional tax. If, however, you would like to order it from the Chinese warehouse, they do collect VAT at sale for EU-based customers. Inside the box we get some documentation, one oscilloscope probe with the accessories. A while ago I reviewed the Handtech LCR meter in Voltlog 303, and as we can see the two have approximately the same size and thickness, which is roughly the size of a big and thick portable multimeter, and they're also about the same weight. I'm saying this because from my experience, at least with the people that I have worked with, they generally prefer either a very small and compact size unit that will fit in your pocket, or they would rather go for the larger tablet style instrument to get all of the benefits of a big screen. This guy fits in the middle, so it's not something that you'd fit in your pocket just because it's big and heavy. You'd probably hold this in a toolbox, and you get a 3.5-inch screen, which is not small but not big either. But on the other hand, you do get a bunch of functionality from such an instrument and a performance upgrade over the very small portable units. In terms of how it's built, you do get some protection because the case is designed to have these raised edges to protect the display in case it lands face down, but I would still add one of those smartphone type scratch protection films on here just because the plastic cover will scratch very easily. The physical construction is really good. This feels like a really solid unit, and there is a mix of soft rubber, which is the blue parts of the case, with hard plastic, the gray parts, but they feel good quality. And Owon have been building instruments for a while now, so I believe they know what they're doing by now, and it certainly feels like it could survive a drop on the floor with these increased thickness of the rubber on the corners. And the unit feels pretty stable even when it's set on the tilting bell, and you can certainly press its buttons if it's not placed on a slippery surface. If you are interested in test instrument reviews, you are probably also dealing with PCB design, so let me introduce the sponsor of this video, PCBWay.com. They are a professional PCB factory which is equipped to provide a full service including SMT assembly, 3D printing, CNC, as well as other manufacturing services. So you can get your product from idea to reality in just a few simple steps. Check out their website by going to PCBWay.com. On the top side of the meter we have the two oscilloscope channels plus the arbitrary waveform generator output BNC connectors, and as expected the outer shield is insulated on these connectors because you might be measuring some circuit where the ground point might be floating at some dangerous voltage, and you wouldn't want to touch that when you handle the BNC connections, and that protection is completed when using the oscilloscope probe because that also has a plastic insulation over the ground connection on the BNC connector, but you lose that protection if you use one of these connectors, which just exposes the metal part. On the right side, under this protective cover, you get the USB Type-C data connection and charging port, as well as the 1 kHz test signal output, as it's common on oscilloscopes. You can use this to test the oscilloscope channels and adjust for probe compensation. The front panel holds the buttons as well as the multimeter input jacks, and the buttons have this nice soft rubbery feel, and they are spaced apart far enough to allow you to use them even with some thick fingers. The power button as well as the run stop button are backlit with different colors depending on the state of the instrument. Like shown earlier, this instrument is delivered with a soft carry case, which is not as nice as the hard carry case that comes with the Handtech LCR meter, for example, but still it's nice that they include this because it will help protect the instrument while being transported or put in storage, and at this price point you kind of expect to receive a carry case. Included with the instrument you get a 5V 2A USB charger, a USB Type-A to USB Type-C charging cable, two of these BNC to alligator clip test cables, a set of multimeter probes, which are not great but not terrible either. They are clearly PVC, but at least they are marked on the cables as well as on the probes themselves. And you also get an oscilloscope probe plus its accessories, and you only get a single probe, even though the oscilloscope is a dual channel one. But it feels like a decent probe, no issues whatsoever. The meter runs on a couple of 18650 rechargeable lithium-ion batteries. There is no brands shown on these included batteries, but it's nice that they're included with the meter, and I'm pretty happy to see that they're user serviceable. I like the fact that these Asian manufacturers understand the importance of that. Underneath the batteries, it looks like they have placed a small SMT thermistor, so it's likely they're monitoring the temperature of the batteries either in their firmware or through the battery charging chip. The claim battery life is about 6 hours, and that obviously depends on the measurement mode you have selected on the instrument and the brightness level of your screen, but given the USB Type-C port, you can easily extend that while out in the field with a spare set of batteries or an external power bank. The specs of the unit are pretty decent. You get a sample rate of 250 megasamples per second in single channel mode and 10,000 waveforms updates per second, which is impressive in an instrument of its class. This should enable you to capture some very fast events on your waveform, and the record length is up to 8K points. There's also the ability to save 4 reference waveforms and recall those on screen. The multimeter is 20,000 counts through RMS, auto ranging, and it can measure up to 750 volts AC and 10 amps. Accuracy varies according to the measurement range, but it's decent enough, and it can also measure resistance, capacitance, diodes, and continuity. The arbitrary waveform generator has a sampling rate of 125 megasamples per second with a 14-bit DAC, and it can output the usual sine, square, triangle, as well as a bunch of arbitrary functions, but without too much control over those custom waveforms, so you'll likely run into these limitations if you're expecting to use this as a full arbitrary waveform generator. The boot time on this instrument is really fast. It's something like 3 seconds or maybe less, and that's really important if you're using this on the field. The screen is nice and crisp, and it provides enough brightness even in my bright studio video shooting lights. The user interface is not great, but not terrible either. Like, some things are pretty intuitive while others are not, and it takes some getting used to before you learn how they work. I think there are still some bugs in the firmware, as sometimes the function buttons they register the press. The button icon updates to register that press in the GUI, but it doesn't actually trigger the function, and I'll try to include a clip of this happening. Generally speaking, what you need to know is that you switch through the 3 operating modes using the mode button, and you can access the various settings of the instrument you are selected in a particular mode with the function keys F1, F2, F3 and F4. While you're in oscilloscope mode, you can switch between channel 1 and channel 2 settings using the dedicated key on the user input. You can switch between vertical and horizontal adjustment, once again using the dedicated key, and then you adjust the settings using the arrow keys. So as you can expect, this is not an ideal user interface for an oscilloscope, but you're pretty limited anyways when you consider the available space and the buttons. In my opinion, the only way to considerably improve this is to build instruments like Mixig is doing, have a big tablet-like screens with big physical controls on the side, including rotary knobs. You get a dedicated key for the auto adjustment function, which by the way works very nicely and is pretty fast, and generally you get small icons on screen to indicate the various settings. In oscilloscope mode, for example, you get the channel input coupling. I have AC here, but it can also be DC or ground. Here you see the trigger point, which is at 0 volts. Here you see the capture window. So in general, you get a view of everything that you need to know. You just need to get used to it. I've connected the Unity UTG962E as a waveform generator to show you something, just because it's a more capable ARP gen, and I've reviewed this instrument in Voltlog 376, and if you haven't seen that video, the short story is that the Unity ARP gen is an absolute must-have for your workbench, but this video is not about that, so I'm gonna stop praising it. I've set it to output a more complex EEG signal, and those 10,000 waveform updates per second really show up here. Like, look at how many updates per second you get on the screen. It just gives you this feeling that you have a high refresh rate and you're capable to catch those periodic glitches when debugging something. However, there is no persistence adjustment. So if you compare it with a bench oscilloscope with persistence adjustment, it's just not as good, because the signals will just overimpose and they remain on screen for too long. In multimeter mode, you get yellow text on a black background and some pretty nice and big digits, and this is quite a good contrast. Personally, I would have probably made the digits even bigger, just because you have the space to do it. The update rate is about 4 to 5 measurements per second, I believe, and that's not bad, but nothing to get excited for, and there is no bar graph display on this meter. If you try to switch to current measurement, it will warn you on screen to have the leads connected to the correct input jacks. Accuracy wise, I've tested this multimeter against some of the voltage and resistance standards that I have here in the lab, and it meets the spec with no obvious issues. The continuity tester is latched and very fast. Even faster with a better pair of probes. The diode tester outputs 3.3 volts, so that should allow you to test all kinds of LEDs. And now the capacitor tester can measure from 1 picofarad up to 2 millifarads, but for anything higher than a few nanofarads, the measurement will be extremely slow. Like it seems like a combination of slow charge time combined with slow auto ranging, and the slow auto ranging is generally present on all of the measurements as well. But you do get the possibility of switching the ranges manually using the range button. And I like how everything is laid out in multimeter mode. It's very clear on screen. Once you switch to the arbitrary waveform generator mode, you get the usual adjustments, but for example, the way the frequency input works is a bit confusing, especially at first time using it, because by moving the cursor left to right depending on the selected digit, the multiplier changes, like from kilohertz to megahertz, and that just feels confusing for me. But I really like how you can turn on the waveform generator, then switch to oscilloscope mode, turn that on, and it will continue running the waveform generator in the background, and this means you can like feed back the signal and measure it at the same time. And once again, here the auto function just works beautifully. I just feel like they should have included one of these short BNC to BNC cables inside the box, just because of the educational value this can have, because you can feed in your own generated signal and measure it. So with this kind of functionality, you can see how this would work nicely as an educational platform for beginners or students, with the disadvantage of not having a full-blown user interface that would teach a beginner how an industry standard interface for an oscilloscope or ARP gen would look like. As far as the PC app goes, it's a disappointment, but one that I was expecting, as it's usual with these instruments. It lacks functionality, it's non-intuitive, and buggy. You can get a view of the waveform if that's what you need, but you don't get a nice set of controls next to that. You have to open the special menu if you need to adjust the controls, and you have to stop the the data download to do that, so I would say it's not a usable app by my standards. But I don't think you would need that feature anyway with such a portable instrument, which is most likely going to be used in the field. My unit is running version 3.3.0, and we notice there is an option for a firmware upgrade in the menu, but there is no update available on Owon's website. And if you have one of these, let me know in the comments what firmware version is yours running. Now let's continue with the teardown of this instrument to check out the internals, and it looks like there are 4 Phillips screws on the back to remove before getting access to the inside. And I expect to see a lot crammed into this unit because it's a 3-in-1 instrument and you would need separate circuits for each one of those instruments. And wow, as expected, this PCB is packed, but on a first glance I don't see any application processor on this side because that should be something very obvious. It should be a big package, so it must be on the other side of this PCB. I also don't see any ADC. That should also be on the other side. So I'm gonna just take this PCB out and take some high resolution images, which you can find in the blog post linked below. And I'm gonna be right back after identifying some of the chips on this board. I removed the motherboard from the instrument, and to my surprise, and I'm very happy to find this, but this is almost a single board construction. Like, you could call this a single board construction. Sure, they have a secondary board here with just the buttons, which is understandable, but I'm really happy to see that they managed to integrate everything into a single PCB. And this means a lot in manufacturing because there is less to handle during production. You just have one big board to test, and once that passes all of the testing, it's good to go and can be installed into the instrument, and there is less to go wrong, even with the operators assembling this on the assembly line. So I've taken a closer look at this board, and here is what I identified. Now, on the multimeter input, we have a 10 amp 5x20mm protection fuse for the 10 amp range, and a smaller 250 milliamps rated soldered fuse. And I'm not sure if this is a resettable PTC or not, but it better be, because it would be really hard to get in here and desolder this fuse and replace it. There are also a bunch of MELF input protection resistors in here, as well as some 0805 resistors in series. There is a bridge rectifier on the other side of this board. Then we have a big shunt and a smaller shunt also on the multimeter side. The multimeter chip is on the other side of this board, is this one right here, and it doesn't have any markings on it, but I'm sure this is just an off-the-shelf part, just a 20,000 count ASIC chip designed specifically for multimeters, and they have no less than 9 of these slim surface mount optocouplers because the multimeter section is completely isolated from the rest of the instrument, and that is obviously for safety purposes. There is a BQ25616 single cell battery charger, which takes care of all of the battery charging as well as the temperature protection on the battery cells through that small thermistor which I showed earlier. And interestingly enough, this chip from TI also integrates a 5-volt boost circuit, and on that note, there are a bunch of other small circuits scattered all over the board, generating the various power rails that are needed in this system, and I believe there are quite a lot of power rails needed for this. And there are also a couple of 6-pin SOT devices right next to each of the negative terminals for the battery socket, and I believe these are in charge of battery protection or maybe cell balancing each of these cells. We also have a genuine bodge in here in the form of this electrolytic capacitor, which was an afterthought soldered in parallel with these ceramic capacitors, but it should be all good given that both of these electrolytics are attached to the PCB using elastics, so these won't vibrate away easily. We have some nice attention to detail in the form of this conductive copper foil, which I assume is to cover maybe some relays on the input section which are sticking out through the metal shield. Now flipping the board to the other side, this is where all of the digital and analog magic happens. We have a GDF32F303 microcontroller in here. I assume they went with the GD instead of the STM just because it's cheaper and easier to source. Like the lead times these days on ST microcontrollers are something like 2 years, so nobody's gonna wait that long. Then we have an Analogic Eagle series FPGA with a part number of EG4X20BQ256. There is obviously a high-speed type interface between the FPGA and the application processor, judging by the length matching on these squiggly traces, and the same can be said for the interface between the FPGA and the DAC 904E from TI, which is our 14-bit DAC taking care of the signal generator output. And once again, we have length matching on the signals between the FPGA and the ADC handling the oscilloscope input, and this is the MXtronics MXT2088. Now, according to the datasheet of this chip, this is a dual channel 100 meg samples per second 8-bit ADC per channel. So I don't know how Owon is getting their 125 meg samples per channel, but maybe they're overclocking this ADC. I don't know. It's not uncommon to overclock these ADCs. The entire analog front end is under this soldered can, so I can't get in there to show you the details, but I guess it's safe to assume it's the same board for both the 40 and 70 MHz version, and they're just controlling that from the firmware because it doesn't make any sense to produce two different boards. So in theory, I believe it is possible to hack this. And I'm gonna say this again, I really like the fact that they've integrated almost everything on this PCB. They only have the keypad as a separate board. So that level of integration surely helps during production, and it also helps keep the cost down. The PCB build quality seems to be very good. The soldering on this board is good with minimal amounts of flux residue, which can be visible just around the through hole parts. There's nothing wrong with that. There are two JTAG ports. One is here and another one here, and there is also a UART labeled header here. So those who are interested in taking a peek can certainly probe these ports. And the board I have here seems to have a date code of May 2021, so it's fairly recent, and it's version 2.1 of this hardware. I've got the unit back together, and now I'm ready to give you my final thoughts on this instrument. I'm gonna start by saying that Western test equipment manufacturers should be worried about their future, especially in this budget segment, because I think the Asian test instrument market is slowly taking over by providing better value for money and by increasing the quality of their products year by year. That's not to say there are no problems with this unit, and I've shown how the user interface has some bugs, how the controls are not the best and not always intuitive, the auto ranging is pretty slow, the PC app is useless, but there are so many good points as well. And when you consider the price range, I think this is really a good instrument for those that need a portable oscilloscope or arbitrary waveform generator. But when you also add the 20,000 count multimeter into the equation, then this is a no-brainer. I would much rather take this with me when debugging on a remote job than carry 3 different instruments. But all of this with a couple of conditions. If the job fits the specs of the instrument, and if this form factor suits my needs. And that's something that you have to consider as well before making the purchase. Is this form factor something that you can work with? Are you willing to accept a less than ideal user input panel? Then by all means, this is good value for money, especially right now as it's on special on Banggood.com. So should you decide to order one, check out the link I've placed in the description of the video. You won't be disappointed by this instrument as long as you consider its limitations. On the other hand, if you're hoping to replace a full-size desktop oscilloscope, then you might be on a path for disappointment, as this kind of portable instrument doesn't have the capability to do that. I hope you enjoyed this video. Don't forget you can support the channel on Patreon with as little as $1 per month, but if you don't feel like doing that, just smash that like button because it really helps the channel in the YouTube algorithm. Thank you for watching, and I will see you next time.